Alright lads, this is just a short video explaining how to the Hyperboloid of Revolution question. It tells us figure 18.62 shows the elevation of a hyperboloid of revolution which has been cut at the top. The true length of all full elements on the surface of the structure is 21 meters. Part 1 tells us to draw the plan and elevation of the building. Part 2 project an end view. And part 3 find the true shape of one side of the cut section. To start off this question, we're going to focus on actually drawing the hyperboloid of revolution in plan. In the question it tells us the throat circle is a width of 6 meters and the height from the ground up to the centre of the throat circle is 9 meters. So I've measured up the equivalent of 9 meters there and went out equivalent of 6 meters in total for each side there and there. We're told the length of the actual elements are 21 meters in total, so as a true length we'd see them as 21 meters. We know that in order to find the element of the true length, we take a tangent at the throat circle. So a tangent at the throat circle will give us the true length. So what we do is we take half the distance in our compass, the equivalent of 10.5 meters plus 10.5 meters equals 21. We swing that equivalent from the center, touches the ground there and there, and also touches the very top here and here. When we take those points down, they hit our asymptote at this point here, and we take these ones down here, hit at this point here, and that as a result gives us a point on our base circles. So you can see there where I drew my base circles. After that we use the regular method of actually drawing the hyperboloid of revolution. We just take points along our asymptote and rotate them up and around and take them out to get points. And then after that I just copied my points across and over using my compass because they're equal distances above and across. After that then I draw my 30-degree cut lines. That's where the cut is actually going to take place. I'm just showing now, for example, how to get points in my plan. So in each cut you take across, every cut that's taken horizontally always produces a circle in plan. So for example, the one in red is the distance from the center out to the edge of the hyperboloid of revolution. Taken down, it appears a circle in plan, and where that cut hits our actual cut surface, I take them points down and it gives me a point here and here on my actual cut in plan. And because it's symmetrical on the opposite side, I can just step that distance across there and step that distance across here. What I'm then going to do is repeat it with all of these points along here, repeating the same step of taking horizontal cuts, drawing circles in plan and taking my points down. So you can just see a close-up view of my plan now showing all my cuts I've actually taken. So it produces all these points here. What we'll then do is draw them in freehand, just like as shown there. After that I'm going to label all of my points because I'm going to use my labeled points to find my corresponding points in my end view. For the end view, all the way up to the cut, the hyperboloid of revolution will always look the exact same. So basically what I did is I've taken all my points across. All these widths are the exact same. So for example, the width from here to here is the exact same as here to here, all the way up to my cut. After that my cut begins to change and I take my points from plan across. So you can see there, for example, the point taken from E goes out, up at 45 degrees, straight up, and where the equivalent is of it, sorry, for point G. Taken all the way up and across, and I take G across there and that gives me a point. I repeat that over and over again, taking all of my distances up and across. And what I can then do is, because the shape is symmetrical, I can step my distance across to the opposite side. For the cut, I'm just using an auxiliary view looking in perpendicular to it, and I get all of my widths from the actual plan. So you can see there that green distance, for example, there from F. I follow it up, I take it down, and I step that distance across there and there to actually complete the question.